Okay, welcome back. Earlier on our Facebook page, I posted this question paper or these problems. So now I just want us to quickly work on this problem to quickly get solutions. So here we have a statement there saying, as you can see, two boxes P and Q, right, are resting on a rough horizontal surface, and they are connected by by a light inextensible string. The boxes have masses of 5 kg and 2 kg respectively, and the constant force F is acting at an angle of 30 degrees to the horizontal. Is applied to the 5 kg box as shown below. So this is what we can see, and it's explained by the statement. So the first question says you must state Newton's first law in words. So this is easy, but I want us to work on this thing together. So Newton's first law states that an object will remain in a state of constant motion or at rest until an unbalanced force acts upon it, right? Or you can rephrase it and put it in whatever way you prefer, but then it must make sense. Right. So 2.2 says you must draw a free body diagram of box Q. So let's quickly do that. So I'll say we'll start at 2.2. As we can see, this is box Q there. That's box Q. So let me just rewrite box Q. This is box, or let me just write everything. This is Q 2 kg because we're going to work from this page, and then you have a string there, and then this string is connecting the 5 kg weight, and this 5 kg, this is the horizontal 30 degrees, and your force F pulled in that direction. And then after they pull this 2 meters per second acceleration in that direction. All right, so this is the surface. Right, so now let's the first question, they said draw a free body diagram and you must label it fully. So now this is how you write a free body diagram. You must remember the first step in solving physics or any physics question is to draw a free body diagram, because it will make things easy for you. Right, so now here if you have to draw a free body diagram for Q, this is what we're going to do. We'll just draw a dot representing our box Q. So there are 4 forces acting here. There's a normal force. You must be careful when you write these arrows to show this is a normal force, and the normal force is equal to the weight or the gravitational force, and then there's a force of the string. This is a tension force. So now we also have this force Fk. This is a force of friction. Can you see the difference between my tension force and this one? They are not equal. The tension force is bigger than that one, right? So okay, we are done with that. So once we're done with it, this is just simple 4 marks. So 2.3, they're saying there box P experiences a constant frictional force of 5 Newton, and box Q a constant frictional force of 3 Newton. Right, so now they say calculate the magnitude of force F. Okay, let me show you the paper again. Okay, let's read again. Box P experiences a constant frictional force of 5 Newton, and box Q a constant frictional force of 3 Newton. Then we must calculate the magnitude of force F. So now we want to calculate the magnitude of this force, but in order to get there, we have to start there with the 2 kg weight or with box Q, right? So now to do that, it will help us to actually get to that it will help us to get to force F, right? So now since we have written all the force acting on box Q, then our work become easy. So now we'll just say you know that force is equal to mass times acceleration, and this must be force net or total force which will accelerate this object. So now let's write all the forces acting here. So we have tension force, right? Because it is actually the force that will accelerate the object in that direction of this force, right? But then there's also a force acting opposite to the tension force, which is Fk, right? So now this total force is equal to mass times acceleration. So now let's start substituting our values here. We don't know our t, right? But we know our Fk. So we'll say plus, but our Fk is acting in the opposite direction. And since it's acting the opposite direction, then we're told that the frictional force is negative. It's not negative 3, it's 3, but because acting in the opposite direction, see I've put a negative there. So equal to mass, our mass is 2 kg times, but acceleration is 0 because our objects rather were at rest. So our acceleration will be 0. So this gives us t minus 3 equal to 0. So now we have t, right? T is equal to 3. So now we calculated our tension force. So this tension force will help us to get there, because now this tension force is acting in the opposite direction in addition to the frictional force acting there. So let's continue. So now I'll say therefore for P, this was for Q. So for P now, for box P, we'll say force net equal to mass times acceleration, right? Okay, I'll shift this side a bit. So now all the forces acting here on object P. So the forces acting there, I will say, as we can all see, we have the tension force, right, plus Fk acting there, plus the force that is accelerating. Now we have to be careful. Now we want this force accelerating that object, but this force was pulled at an angle. Yeah? So it was pulled at an angle, but then what is actually accelerating this box is the horizontal force. So we have to find this force here. So let's just quickly write the free body diagram of just the 5 kg because we didn't do that. So this is what it will look like. We'll have the normal force, we'll have the G, and we'll have tension plus Fk, and then we'll have that one, the F, and then we'll have 30 degrees, or we can call it theta for now, and then what we are looking, let's just call this one X for now. So now we have to find this force there. So now as we can see, we have this right angle there, which can help us calculate the horizontal force acting there. So to do that, let's say we're trying to solve for X because we're looking for the horizontal force. So we'll say, okay, like let's bring back our imagination of of our what working with angles, for example, our trigonometry knowledge. So this, if we had to solve for x here, this will be x equal to f cos theta, right? So now our horizontal, let's pretend the horizontal force now it's this x. So this is the force we're looking for. So now we'll take that plus here and say f cos 30 degrees, because our theta there is 30 degrees, and then is equal to mass is 5 kg times acceleration, right? So now let's quickly substitute everything. Our tension force we calculated is 3 plus Fk we're given is 5, but then these ones are acting in the opposite direction, so I'll put a negative there, plus F times cos 30 degrees equal to 5. Our acceleration is 0 because remember these objects were at rest, right? So now this will be F cos 30 degrees minus 8. Gonna add those two, then this will be 0. And then now simple mathematics, F cos 30 degrees equal to 8. And then F will be 8 divided by cos 30 degrees. And then F, when you use your calculator properly, it will give you, a value of 9.24, right? So that's how we solve this whole problem. So I hope it makes sense and you understand. If you don't understand, please remember to text in the comment section and ask whatever you want to know. So now we continue with our paper here. So as we continue, we get this diagram there where it says okay, the string connected P and Q suddenly breaks after 3 seconds while force F is still being applied. Learners draw the velocity time graph for the motion of P and Q before and after the string breaks as shown below. So now as you can see this graph, write down the time at which the string breaks. Like we were told that after the force F was applied, after 3 seconds, this string broke. So we can say for our answer for 2.4 is just 3 seconds, right? So for 2.5, which portion of x, y, or z of the graph represent the motion of box Q after the string breaks? Use the information in the graph to fully support the answer. So now we have z just shows while everything was still at rest, and x, it shows acceleration. But then what we know is that after the string broke, everything, like we will have to, okay, maybe P will continue moving, or maybe perhaps x shows what happens with P. But as for Q, it will constantly stop, right? It will decelerate. So here y shows the motion of box Q after the string broke. So yeah, that's how you can go about it. I hope it made sense and you understand. Please remember to share with everyone. Knowledge is power, and if you don't have or if you have any questions, please remember to ask us below in the comment section. Thank you.